Algebra 1 students, welcome to your 3.8 notes on unions and intersections. I think that October, the month that we have Halloween, is the perfect time to break out our X-Files theme song. And so did somebody else, which is why they requested it. So there you have it. Unions are the union of two or more sets, is the set that contains all elements of every set. And we notate that by this U-shaped symbol right here. That's what we're talking about. And an intersection, the intersection of two or more sets, is the set of elements that are common to every set. So on an intersection, we've got this filled in area right in here. All right, it's got to be common to both. In a disjoint set, no elements are in common. So we have a couple of words here that are kind of connecting words for when we use a union or when we use a intersection. And so if there is the word and involved, or if you would use the word and to describe the situation, we've got an intersection. And if you would use the word or to describe the situation, you're going to have a union. Okay, so those are kind of two words that are going to help you remember which one to go with which. All right, so our instructions are to find each union or intersection. And we've got a set for A, which is 1, 3, 5, 7, and 9. And then we have a set for B, which equals X, such that X is a positive odd integer less than 10. All right, so instead of just trying to remember what that set is by looking at it every time, I'm going to write down what it is. And so here we go. We've got positive odd integers less than 10, so that's going to be 1, 3, 5, 7, and 9. Wouldn't you know, it's the exact same set as B, or as A. So basically, when we are given number 1, where it says that we have the union of A and B, well, all of those numbers work for both of them. So I'm going to go ahead and write that down. I've got 1, 3, 5, 7, and 9. And before I really get going any further, what I really should do is kind of figure out what is in my set for D, because that one's not listed for me as well. So we've got D equals X, such that X is a negative integer between -5 and -1. So D should be -4, -3, and -2. It can't actually include 1 and 5. All right. So, number 2, I've got D union C union B. So basically in that one, I've got everything that I'm going to see across all 4 of those sets. I'm going to put them in numeric order. Okay. So I've got my negative ones first. So I've got -4, -3, -2. All right. And as I look up this direction, I see a couple in C that I haven't taken care of. Actually, everything in C. And so I'm going to have 1, 2. I've got a 3 up here in A and B, so I'm going to use 3 as well. I've got a 4 here. I've got a 5 in A and B, and I've got a 7 in all 3 of those. And then I've got no 8s, but I do have a 9. All right, that should be all of those, so I think we've taken care of that. Go ahead and pause the video try number 3 on your own. Alright folks, welcome back. Hopefully you actually paused the video and tried number 3. So I've got -4, -3, -2, 1, 2, 4, 7. If you wanted to, if you were to start over here with the C and then go over here to the D, so you had all your positive integers first and then listed your negative integers, basically in the order that you had seen them, that would work as well. Alright, for 4, 5, and 6, we are dealing with intersections. So that means it has to be listed in both sets in order to be considered for the new set for the intersection of A and C, for example, for number 4. So the only numbers that I see that work in both of those, let's turn on the pen here. The only numbers that I see that work for both of those are 1 and 7. Okay. Boy, my brace is kind of weird looking there, but I think you get the picture. For number 5, we have to have a number that works for A and C and D. Well, folks, D has only negative integers, so if it has to be in all 3 of them, that kind of eliminates everything. So basically we have the empty set. So we just draw a 0 with a line between it like that. Okay, so that's how you take care of the empty set. And in number 6, try that one on your own. Go ahead and pause the video. Folks, number 6 was pretty easy. It was another empty set. Hopefully you actually gave that a shot. On to the next one. Alright, for number 7, it says draw a Venn diagram to represent the union and intersection of these sets. Guys, I was not very fast at doing that, so I basically had to cut out what I had done and basically just show you instead of hanging out with you while I fumbled around with drawing all of that. So there's my Venn diagram. M, A, and D were just in V. We've got M and X sharing E, and then all 3 of them share P, and then we've got V and W that share the letter B. So that is my Venn diagram. Try number 8 on your own. Basically make something kind of like this. You can do it. You can handle it. Alright, at number 8, the letters in the word algebra, geometry, and calculus are represented by the sets listed here. Not every letter is listed every single time because sometimes if there's a duplicate letter, you don't need to use it again. For example, vowels like A. So anyhow, hopefully you had some fun plugging in the letters of algebra and geometry and calculus into your Venn diagram. Here's what I came up with, and we'll see you on the next slide. Okay, solve each inequality. Write the solution as either the union or intersection of 2 sets. So first I need to manipulate this algebraically by subtracting 7 from all 3 pieces. When I do that, I get -13 less than n less than equal to 14. Alright, anytime I've got a situation where my variable is sandwiched in between these two, both of the conditions need to exist. Alright, so if I were to write this in interval notation, I could say that -infinity, and then I'm going to include 14. Alright, and which means that I've got the symbol and in between there, which is kind of synonymous with intersection. Both of these things need to occur. And then so I've also got -13 to infinity. Okay? So that word and kind of tells us that we've got an intersection going on in between there. Okay, so for number 10, I'm going to use my little trick where I am going to set up my two possible outcomes. So I'm going to break 5x plus 11 out of jail, and I'm going to set up my inequality over here as well. So that way I know which direction my inequality is going to go. It's kind of weird because it's not in numerical order, but again, this is how I like to do it so I don't mess up which direction my inequality goes. So anything I do to one piece, I got to do it to all three pieces. So I'm going to subtract 11. Going to end up with, let's see, a negative 7 over there. All right, 5x in the middle, less than or equal to, and then I've got a negative 15 out that direction. Okay, now I can divide all three sides by 5. That one's not going to be nice. All right, so I'm going to have negative 7 over 5 less than equal to, well, those 5's are going to cancel out, so I've got x there less than equal to a negative 3. Okay, and that's kind of weird order to have because negative 3 is actually less than negative 7 over 5. So what I'm going to do is rewrite this. So I've got x less than equal to negative 3 or negative 7 over 5 less than equal to x. And if I was to think about this graphically, I would have a filled in solid circle right there at negative 3, and x would be everything less than. And then I would have a filled in solid circle at negative 7 over 5, and x would be everything greater than that. So that's what my graph would look like. So I'm going to have a union where I've got negative infinity to negative 3 inclusive. Okay, and then the OR symbol is synonymous with the union symbol, and then I'm going to have negative 7/5. I did not leave myself enough room right there. That looks horrible. Okay. Negative 7 over 5 to infinity. And that is how number 10 should look. Go ahead and pause the video and try number 11 on your own. All right, ladies and gentlemen, hopefully you actually paused the video, tried number 11. You should have gotten that negative infinity to negative 1 is an intersection with negative 7 to infinity. And that's kind of how you do that one. I did a little trick on this one where I've got my entire inequality and then I flipped it all over right there. So if you're wondering what in the world Mr. Bear did, I did that for my own sanity. And that concludes your notes today. Enjoy your X-Files creepiness. Come to class ready to work.